Hi guys, we're back to talk about the Pleistocene glaciation lab activity that we're going to do. So I'm going to walk you through some of the instructions for how to manipulate the data in Excel. So I'm going to share my screen and we're going to look at, which one is it? I think it's this one. Okay, must be this one. Sorry about that. Okay, so basically you're going to download this Excel spreadsheet, this Pleistocene glaciation spreadsheet. And when you open it, there may be a little like warning at the top that tells you have to enable editing. So you want to go ahead and click that. I don't have to do that since this is something I made on my computer. But once you do that, there's going to be 3 tabs here. There's going to be a hydrogen tabber sheet, an oxygen tabber sheet, and an insulation tabber sheet. So we're going to make graphs of the hydrogen data and the oxygen data. And remember, both hydrogen and oxygen have different isotopes, different versions of that element that have different numbers of neutrons and therefore different weights. And there's heavy and light versions of both hydrogen and oxygen. In the case of hydrogen, the heavier version is called deuterium. So you might see that and say, like, wait a minute, that's not hydrogen or oxygen, but that is hydrogen. It's a heavy version of hydrogen. And then in the case of oxygen, we refer to oxygen 18 and oxygen 16 as the heavy 18 and the light 16 version. So basically in the environment, the temperature of the environment impacts how readily the different versions of these isotopes circulate in both the atmosphere or how they get concentrated in the oceans. And generally, when it's warmer outside, it's easier for the heavier versions of the elements to end up circulating in the atmosphere. And when it gets colder, there's not as much energy in the system, so the heavier versions tend to fall out of the atmosphere and get concentrated in the oceans. So we actually see kind of an inverse of what's happening in the atmosphere and in the ocean, depending on temperature, with heavy and light versions of different elements. So we're going to try to graph these different things and look at how they compare to the different glaciation events and how they compare to the different Milankovitch cycles that we mentioned control some of the solar insolation arriving at our planet. Okay, so the first thing that we want to do is look at the hydrogen data and the deuterium data. So we have the first column that shows us the thousands of years before present. So there are these small fractions, but 0.017 thousands of years before present is basically 17 years before present. And then there's a lot of data going all the way back to about 400,000 years before present. And then there's these different delta D ratios. And remember, these delta ratios are the ratios of the heavier and the lighter versions of the isotope. So you divide them by each other, and then you get this ratio, which in this case is negative. And they vary over time, telling us a little bit about the conditions of the environment. So the first question asks you to search for the maximum and minimum values of deuterium. And you could do that by scrolling through this whole thing and looking for the highest value and looking through the lowest value. But Excel has an even easier way to do this. You can click in an empty little, they're called cells, these little boxes in Excel, and you can do commands. So there's one command that allows you to find the max value over a range or the minimum value over the range. So we can say equals in our cell. Anytime you want to do a calculation or a function, you start with equals. And then we're going to say max. And as we start typing, you'll see these different options come up. We want the maximum value. And then max, there'll be the opening of a parentheses. And then what we do is we come over to this deuterium data. We click on the top number, not the title, just the top number. We hold our finger down. We don't let go. And then we drag all the way down, highlighting all of this data. And it's going to take us a while because there's a lot of it. We're only at 130,000 years ago, 140,000 years ago. So we are going through thousands of data points to the end. Okay. And then we come up here to this equation box up here and we close out the parentheses. And then the equals button, like on a calculator, in your on your computer is the enter or return button. So if we go back up to the top, we'll find that the maximum value, which is the highest value, is negative 414. So that might seem weird to you because you might say, hey, some of these numbers are higher, like 438 is higher than 414, but remember that all these values are negative. So actually negative 414 is a higher number than negative 440 or 438. Okay, so then we can do the same thing to calculate the minimum value. We could say equals min, and then we could either highlight all those numbers. That's probably the easiest way. We'll just do that. We'll go down and highlight all these numbers again. Takes a minute to get through all this data. 300, 400, going back about 400,000 years. Okay, and then the minimum value, the lowest value is negative 488. So these are the ranges as the air gets warmer, the value gets higher, closer to 0, and then as it gets colder, the value gets more negative or lower. So we could write also max here and min here so that if we or somebody else come back to this, we would have an idea of what those values represent. Okay, the next thing we're going to do is we're going to calculate or we're going to make a graph showing the trends in the cycles in these data over time. So we're going to go up to insert, excuse me, this insert option along the top. And once you go to insert, you should see in the bar up here, there's different options, and we're going to add a chart. We're going to add this chart that has these little dots on it. It's called an XY scatter chart. That's the kind of graph that you make when you have two sets of numbers, two sets of values that you're comparing against each other. And we're going to use this smooth line version over here, number 3. So sometimes Excel guesses the graph that you want to make, and sometimes it guesses right, and sometimes it guesses wrong. So I don't have any data highlighted, so my graph is coming up blank, which is actually the best option. If you have data already in here, what I recommend that you do is you right click inside the data, you hit select data, and then if you have data already in here, it will be listed over here on the left, and you can click it and then you can hit this remove button until it's all blank. And then once you're ready, you want to select data for your chart. The same thing, right click on the graph, choose the select data option. We want to add data. We only have one series name, so we don't necessarily need to add a title, but if we want to add a title here, it will show up as the title for our graph. So we could say delta deuterium values over time, something like that. Deuter, I think I spelled that wrong. Deuterium, maybe. Okay, so then we're going to highlight our X values. We're going to click in the second window here, and we're going to come over and we're going to click, again, not on the title, but on the data. And we're going to have this cell here, 5, and then we're going to drag all the way down, all the way through all these years. And when we get all the way to the bottom, we can stop. And I'm just curious, it's not showing very well here. This is row 3315. I'm going to make a little bit of note of that to make my life a little bit easier. And then I'm going to say, okay. And then I'm going to re-edit the same value because I actually didn't add any Y values yet. That's going to be the data that's moving up and down along the vertical part of the graph. So the horizontal part of the graph is going to be showing time. That's what we already put in. Those are our X values. Our Y values have this placeholder that we have to delete. And then I could also just go back up to the top, click and drag down through all these values of the delta D and the column B. But I can also just basically type in this little thing above hydrogen. That's telling what sheet we're on. Explanation that tells us that we're taking data from this tab. And then there's a $sign, But instead of the A column data, I want the B column data. So I'm going to say $B, $5, colon, $B, $3315. So basically I'm just copying that equation right from the X values above. So I'm just saying I want all the range of values that match the values in the A column, but I just want you to pull the values from the B column instead. So maybe that's faster or slower, depending on who you are, then highlighting all that, those 3,000 cells of data. But when I'm done, I'm going to say, okay. And then if I scroll back up to the top, I should have a graph. Okay, and this is showing me my delta deuterium D values over time. Wait, oops, I accidentally deleted my chart title. That's fine. So first of all, I want to make a couple edits to my chart. So first of all, I want to reverse. I want to click on this axis that's actually along the top, and it's along the top because all these values are negative. Usually when you make graphs in Excel, the axis is along the bottom. These represent the thousands of years in the past. I'm going to click on this data and I'm going to say, or I'm going to click on this axis and I'm going to right click on it till I see this option that says format axis. I'm going to come over here and I'm going to say, I want values in reverse order. So I want to show it from the present going back in time. That's kind of a more standard view that we usually see for this data. I'm also going to just clean up this a little bit. If I right click on here and say format axis again, I'm just going to have it go back 400,000 years because that's kind of a cleaner number right here. Okay. And then down here, these should be our delta deuterium values. I don't know if there's a way to put that on the bottom. There probably is. I don't remember. Anyway, it's not critical. So the other thing I want to do is I want to go to my chart elements and I want to add a chart title and I want to add axes titles. So first of all, I can click inside my graph and I can actually make it a little bit smaller so that there's more room for my axes titles. But first of all, here's my delta deuterium values over time. I guess maybe I didn't delete it, or just pulls the series name. Along the x-axis, what we're seeing is thousands of years before present. And then this is showing our delta, I guess we have to delete delta. And that's usually like shown as like the Greek symbol delta, but it's just a little bit tricky to put that on the computer. You can do it, but I'm not going to walk us through how to do that. So these are the delta deuterium values. Okay. And then again, I can click and drag these pieces around. So if I'm clicked on them, I want to wait till I have this like X with the different arrows that will allow me to drag it. And maybe I could even add as collected from ice core data if I want to update my title a little bit. Okay, so I have this graph. This is showing peaks and valleys of delta deuterium values. And so we can see that this is something that has changed over time, going back 400,000 years. There's peaks, there's valleys, there's peaks, there's valleys, and then there's lots of little peaks in between these valleys, but you can kind of see, you know, there's like 1, 2, 3, 4, at least kind of major peaks through this period of time. Okay, so that's how we make our hydrogen graph. And then there's some questions to answer about that. Then we're going to move on and do the same thing for oxygen. I'm just going to run through this more quickly for time. And then I want to show you the last part, comparing the graphs together. So let me just quickly go to insert, graph. Okay, I'm going to select my data by right clicking in the graph. I'm going to add data. I'm going to call this delta or we can call this oxygen isotope ratios over time. And then this is collected from sea sediments. So this is ocean data rather than atmospheric data. So my X series values are going to be these values over here. The time going back to 400,000 years in the past. There's not actually quite as much data on this one. So there's only about 400 rows versus thousands of rows in the last one. Then we go to add our Y data. This is the data that's going to show vertically. So this is the data about those ratios. Remember, we have to highlight and delete that little 1 in bracket placeholder. We'll go up. We'll highlight the data. Okay, and then we'll say okay, okay, and then we scroll back up to the top. We should see our graph showing the changes in isotope data over time. We want to add elements to our chart, axes titles and chart titles. Before we actually put those in, we want to do one other thing. We want to reformat our graph so that we're showing data going back in time like we did with our deuterium or hydrogen graph. So again, we go to this bottom axis, we right click on it, we format axis, and then over here we can click this box that says values in reverse order. And then I'm also going to change it so it goes back to just 400,000 years. So it'll kind of have the same time scale as the last one that we saw. We can name this title here. We can just use this same thing that's up top. I think actually if I just click on this, does it show up? Where is it written? Okay, never mind. That doesn't work. I thought that worked. Okay, so I just, as we're adding these things, I want to make sure that if you're clicked outside the graph, then you won't see those options to add elements to your graph. You have to make sure you're clicked inside your graph. If you click on the plus sign, again, we want to add axes and chart titles. We'll click in these little word boxes here, text boxes here. We'll call this oxygen isotopes in cores of deep sea sediments, or oxygen isotopes over time, and from cores of deep sea sediments, something like that. Okay, so we know what this data is showing us. Along the bottom, we want to make sure that our viewer knows that this is thousands of years before present. This is going to be our oxygen isotope ratio, or delta value. But again, remember that delta is kind of hard to show in there. Okay, so now we have two graphs. And then finally, there's some answers you're going to answer about these graphs. And then finally, there's an insulation graph that I already made for you in the interest of time. This shows our understanding based on the Milankovitch cycles, based on these cycles of differences in the spatial position between the Earth and the Sun that impacts the amount of solar energy that arrives at the Earth. How we have more and less solar energy coming into the Earth over time. So our understanding, as we talked about in lecture and in the textbook, is that these Milankovitch cycles have an influence on some of the Pleistocene glaciation cycles that we saw. So we're interested in seeing how the oxygen isotope, the hydrogen isotope, and the insulation data all line up together. So the last thing we're going to do is actually copy all these graphs onto the same page so we can compare them side by side and see how these cycles line up. Okay, so we can really actually do this on any page, but if we take the hydrogen graph, we can grab it and we can right click and copy it, and then we can go over to the insulation page, we can click and then we can paste it. And we can do the same thing with the oxygen data. We can click it, we can right click, we can copy, we can go to the insulation page, and then I'm just right clicking and then you can paste it, or Command V, is also, right, an option to paste. So now we have all these 3 data graphs lined up, and we want to line them up and basically like stretch them out so that the 400, the 350, the 300, the 250, the 200, the 150, the 150, and 0 all line up pretty well, which I think they do pretty much on this graph. And then we'll go down and do it on this graph as well. If I click it, if you click inside the graphs, you should be able to drag them around. So here we have our 0, and then we're going to need to compress this one a little bit, or maybe we could, I guess we could stretch the other ones out a little bit so that they line up a little bit better. A little bit more. 0 that way, 400 that way. Okay, we can do the same thing over here. 0 seems to line up pretty well here. And then we'll stretch it out. I'm clicking and I'm stretching the graphs out so they're lined up together. And then we're trying to kind of see if the peaks in the data for the different isotopes line up, or if they seem reversed from each other. Do we see peaks here where we see valleys here, or do they seem more lined up, vice versa? And then we're going to also look and see how this data all lines up on the same thing. So anyway, we're just visually looking at these, and I'll have some questions to ask you about that data as well. Okay, so that's what I'm asking you to do.